Hello everybody, thanks for coming. The title of my talk is How Not to Migrate to a New Application Platform, and this is not a rant about Kubernetes. Hands up if you were expecting a rant. Only 3 people, nice. Though it could be a rant. In Kubernetes there is this resource called Ingress, which is more or less responsible for managing inbound connections from your customers to your cluster, so effectively to your product. And Kubernetes is also said to be built upon 15 years of experience of running production workloads at Google. And yet somehow serving customers is still a beta feature. But as I said, I'm not here to tell about Kubernetes, and I'm not here to tell you about Nomad. I'm here to tell you a story of our migration to a new application platform, and specifically how we approach it and what mistakes we have made so that you don't have to. Please keep in mind that learning from our failure may tell you what not to do, but that doesn't tell you what to do. Slides with that background color, you can consider it as my sort of words of wisdom, something that I learned or we learned the hard way, and always remember to take them with a grain of salt, as I hope you take this one. My name is Mirosław Nagaś. I organize DevOps KRK meetups in Kraków, and I also work as a DevOps engineer at Base. And at Base, we have this homegrown application platform that has been hosting this mess since 2012. So as you can see, before Nomad, before Kubernetes, or even before Docker were launched. What's inside? 85 nodes, 3 terabytes of memory, 1,200 CPUs, 5,500 workers, 150 microservices, written in 5 different languages, using many model view controller frameworks, or not using them at all. So what it has to offer for developers? Configuration management, secrets management, service deployments, including blue-green deployments, rolling deployments, application observability, centralized logging. Couldn't ask for more, right? But I'm not a developer. I feel more like this guy. So what's there for me? Multi-region, multi-data center, high availability, self-healing, easy provisioning, built for scale, community, telemetry. As you can see, we have a huge problem here, or more precisely, we have had a problem here, as there is Kubernetes to the rescue, right? So yeah, we decided to start a migration, and yeah, we failed. But hey, projects fail, right? For many reasons. Bad communication between the relevant parties. Not what happened. Poor stakeholder management. Nope. Inefficient developers. That one is really tempting, but not this time. Change in organization's priorities. That's the one. Change in organization's priorities. We planned it for 10 months for about 4 people, the migration, whole migration. And believe me, 10 months is like a eternity in a fast-paced environment. We were able to work on it for about 5 months, 2, sometimes 3 people instead of 4. Number of production services migrated. Number of production clusters provisioned. I know you want to know how we did it. So this is what happened. It all started at the end of December 2016, when we started planning our roadmap, our team roadmap, and we started scoping the migration products, codenamed NextGen. A month later, by the end of January 2017, we have this great plan, 6 milestones, and we started executing it. What you see here is just epics. So inside epics, you have actual stories and actual tasks. So as you can see, lots of stuff. So where are we? Mid-May. Here, mid-May, at least according to the plan. because in reality it was mid-June or even further. So what is it? February, March, April, May, June. 5 months. It was 5 months, and we were just about to start working on non-production environments, as you can see here. So what we were doing for about 5 months? It was 5 months full of planning, full of research, conceptual work, and proof of concept. Of things like cluster provisioning and management. I know it's all blurred here, but you have to trust me that there is a legitimate content there. You have requirements and you have tools there, and you have to check and test each tool to see what requirements it satisfies and what aren't. And you need to get a feel of the tool, whether you like it or not, and want to use it or not. Routing, you have to also somehow solve this problem. So you have to know how your front end is going to communicate to your old platform and to your new platform, how your big data stack is going to communicate with your new platform, how your new platform is going to communicate with your old platform, and vice versa, how your new platform is going to communicate with third-party services. And by third-party services, I mean stuff like MySQL databases, Redis clusters, RabbitMQ, and so on and so forth. Load balancing. I was impressed by the number of ways you can deploy Linkerd. You can do it per host as a daemon set. You can do it as a sidecar, and when you choose sidecar deployment mode, there are 3 configuration ways you can do in regards to how applications are gonna to communicate with Linkerd. It's linker to linker mode, it's linker to service mode, and it's service to linker mode. You can deploy Linkerd with NumRD service or without NumRD service. And if you are using CNI networking plugins, there are also a different set of settings you have to set to make to enable the CNI configuration. And in general, you have to do it for all the tools you are interested in. Configuration management. You have to configure somehow your application. You have to provide secrets to your application. These things has to be stored somehow and somewhere. So you have to research the topic, you have to create an attack plan, and then you have to implement it of course. And nowadays, everything needs to have an UI. So you will also elaborate on it a bit, and a bit more, and more, and more, and more, and one more time. This is only about UI for configuration management. Deployments. You also want to deploy your application somehow. We chose Helm as our packaging solution, in fact, including application deployments. And there was an issue with secrets there, because it only allowed you to use Vault from HashiCorp, or you had to pre-store your secrets in Kubernetes. We were not interested in any of this, so we created a plugin for Helm so that you can store and manage your secrets from Git using normal Git workflow. It is open source. You can find it at futuresimple/Helm secrets, and we have a blog post about it as well. I encourage you to read it. Commercial support. That one is funny. As I said, we have no production cluster. Hell, we never migrated any service to Sandbox, in fact. But for some reason, we decided that we want to be really safe, and we wanted to find companies that provide commercial support. We compared them, and in fact, with some of them, we even contacted regarding the contract. When we chose Linkerd as our load balancer solution, we also talked with its CEO about the possibilities of commercial support, and I must say that he was even impressed that we did it, and he was a little bit shocked and asked what is wrong with their Slack channel. So. Yep. So it was 5 months of thinking and testing. No production service migrated, no production cluster created. But we coded a lot. There were weeks when we created 1,500 lines of code, and we created a wall of text. But why? Why to approach it like this? So there is this guy, Fred Brooks. He is best known for managing the development of OS 360. And this book, The Mythical Man Month. Some people refer to it as the Bible of software engineering, mainly because of the ideas presented there, like adding manpower to a late software project makes it later. Or how does a project get to be a year late? One day at a time. But most importantly to this talk, the second system effect, which describes the jump from a set of simple operating systems on the IBM 7000 series to OS 360 on the 360 series, which happened in 1964. And it goes as follows. The general tendency is to over-design the second system using all the ideas and frills that were cautiously sidetracked on the first one. The general tendency is, well, in other words, when an architect designs a second system, it is the most dangerous system they will ever design, because they will tend to incorporate all of the additions they did not add to the first system. And this is basically what we did. When designing our next application platform, we strived for two things. The first one, we strived to please everyone. We are good citizens. We went to other teams and asked them, what do you want and what do you expect from a new application platform? And what security wants? Security wants VPN, security wants VULS integration, security wants Audit D integration, security wants OS query integration, security wants airbag authorization, dynamic sudo-rs configuration, access control list for service-to-service communication, rootless containers, reduce capabilities in containers. None of them were available on the old platform. Devin guy. Devin is a code name for our development teams. So what Devin wants? Devin wants built-in failure injection, built-in circuit breakers, remote debugging, JVM process heap dump, warming up a service before putting it under a full load, running end-to-end tests on a new release before going live, a new release to be automatically verified, for instance, performance degradation or error rates, define his own verification conditions, access to Rails console to perform some data cleanup or other manual tasks, and on and on and on and on it goes. In general, we got more than 100 external requirements, which was even funny for developers themselves at some point. This is exactly what happened. And at that point, we thought that we have two choices. We can either fix it all, or we can either but we are good guys. So we obviously chose to fix it all, and that led to this. We strive to have complete solutions from day zero. And by complete, I mean both feature complete and ultimate meaning lasting for a few years at least. So here they come. Very extreme requirements for something that is at that early stage, for everything, for configuration management, for cluster management, for load balancing. We decided to implement them even though most of them weren't satisfied on our current platform. And the problem was that there was no one to tell us that in fact there is the third option. Keep calm and don't make it worse. If you don't have a world-class cluster provisioning, doing it now is most probably a wrong idea. If you don't have a world-class load balancer, doing it now is most definitely a wrong idea. If your current system doesn't support self-healing, I can hug you, but please don't fix that during a migration. You will be stuck fixing the wrong problem. Been there, done that. The idea is very simple. You create a machine instance, you create the launch configuration, you create an auto-scaling group, you put nodes in that auto-scaling group. When one fails, auto-scaling group will take care of that. But the devil is in the details. When you change your infrastructure a lot, like we do, you have to somehow automate this process. And how do you do this? How do you build AMI? You can build images for one image for all environments, or maybe one image per environment, or maybe one image per instance type, or maybe one image per instance type per environment, or maybe all combinations, or maybe some of them. And building images is just a tip of the iceberg. How to configure an instance after launching it? I guess your monitoring endpoints are different on production and non-production. You have to somehow reflect that. How to roll out a new AMI? It's not enough to update an auto-scaling group. You have to rolling update the whole cluster. Are you able to drain and replace a single node gracefully? If you simply terminate it, you will also terminate your customer's request. I guess they won't be happy. I wouldn't. Are you able to drain and replace your entire cluster automatically? When you are building lots of images daily, doing it manually will take a lot of time. You will be wasting a lot of time. And when you are doing it automatically, you don't want to do it YOLO way. That is not the best idea. So you have to create some mechanism for AMI validation and testing. And last but not least, we started doing it more than 2 years ago. And as you can see from this screenshot, this process is not very stable. Fast forward 2 years, and it is still not very stable. It is not an easy job. And every time it fails, we have to check why it failed. So it also takes time. But do not panic. Just remember that this is where magic happens, and this is your comfort zone, and this is okay. It's always like that. And also remember that migrating to a new application platform is not one job. Let's see what it takes to migrate and run just one production service. You have to create a cluster. You have to handle deployments to both clusters, to both platforms. Yeah, you have to set up routing between both platforms, maybe containerize a service, maybe integrate with existing configuration management system, maybe integrate with existing logging solution, maybe integrate with existing monitoring solution, maybe integrate with existing alerting system. The more services, the more complex it gets. Let's take a more in-depth look from application perspective. You have to take care of application contract, application packaging, application deployments, application configuration, application secrets, application observability, application debugging, application error reporting. And how about security? You have to update your Kubernetes platform somehow. You have to take care of system packages on Kubernetes hosts. You have to update packages in containers. You have to take care of authorization and authentication policies. And how about reliability? We had an issue, a never-ending story with a disk space. Ours was filled by a syslog file, 14 gigabytes, and almost all containers on master nodes were killed and were not rescheduled after freeing some space. We didn't know how to fix that. We replaced the whole cluster. Fortunately, it happened on Sandbox. If that happened on production, I don't even want to think about it. So we have to think about availability and resiliency testing. You have to think about disaster recovery procedures. So as you can see, this is not a one job. Even something simple like migrating to containers. Container is immutable, best practice. It contains everything it needs to run the application, including your source code, good luck talking to security team, and configuration. Good luck with multi-environment support. So it sounds like just about time to move from configuration in files to configuration from environment variables. Container also doesn't store data. Where are my logs then? Sounds like just about time to move from logging to files to logging to standard output and error, standard error. Good luck with unstructured and multi-line logs like this one. You don't even know which request completed. And when you are sending logs to standard output, how do you access them? So it sounds like just about time to create a centralized logging system. Oh boy, good luck. And if you lost track, we are talking about containers and migration to containers, and let's assume you will containerize one service in only 2 days. With 150 microservices, you will be done in a year. Just like the whole year, only containerizing services. And I will give an example of detailed plan. You will plan to fix the application in 1 day, and you will spend 1 day fixing the application. The next morning, you will continue fixing the application, and you will deploy your fixes to sandbox around launch. And you will spend 2 hours testing it, including it in your launch, of course. On staging, you won't test it, because you extensively tested it on sandbox, right? And performance, you are running out of time, so performance testing sounds like a good candidate to cut scope, and you will definitely do that. And at the end of the day, you will go live, because you tested it on sandbox, you tested it on staging, and you tested it on performance, and your automated tests, if you have them, they didn't report any issues, or nobody checked that. And while we are talking about containers, how about building containers? You have to build them somehow, and when you have hundreds of them to build, you have to do it in parallel. How about storing and distributing containers? We chose ECR because we are using AWS, and we started with one ECR, but when you are deployed to many regions, and you are deploying applications 50 or even more times a day, image pool latency becomes considerable. So you start thinking about how to keep your containers close to cluster. So don't be fooled, don't fool others, don't fool yourself. This is not one job. And you may wonder if it would be easier in 2018. Let me ask you a question. Would you use Kubernetes open source distribution or one of the dozens of offerings from other vendors? Kubernetes distributions from other vendors. Lots of them. Even Huawei launched a Kubernetes-based container engine. So, there is this project from HashiCorp, Nomad. Kubernetes is sort of batteries included approach, and Nomad aims to only provide cluster management and scheduling. So the plan is simple. Replace cluster manager and scheduler, and do the rest sequentially through next iterations. We evaluated it for about a month, so 2 sprints, and we really believed in that plan. And this is what happened. But I have to say that I got texted this morning, and my team asked me to say that we are entirely on, like all our services are migrated to Nomad, and 25% of the traffic, production traffic, goes to Nomad. So yes, in June there is a success after like, I don't know, 6 or 7 months of working. Okay, so what went wrong? We planned it for 2 sprints, and it took us like at least 10 or 15. There is this motto from Facebook: move fast and break things. If they can be that successful breaking stuff, why can't we, right? Especially if you believe in this saying that when you want to see further than others, you have to stand upon the shoulders of giants. So we started introducing lots of changes every day. Or I should have said YOLO, introducing a lot of changes every day. Because most of them were with, fingers crossed, and we became so efficient in breaking things that we even decided to document that. Some of them lasted like for a few minutes, some of them 3 hours, some of them 12 hours, even a couple of days. And boy, we were breaking stuff like crazy. This is a post-mortem of one of the issues, and I believe even Mr. Zuckerberg himself would be very proud of us, especially when reading this. Never ever fix problems by adding new fixes over new fixes. But we were breaking stuff, so why not? Okay, jokes aside, others didn't like it, and they started creating appointments for us, sandbox stability, staging stability review, and we were attending these meetings, and they had one thing in common. When we were there, we couldn't say if issues they see, they were caused by our changes or maybe someone else changes or maybe by the application. We couldn't say that. And of course, we didn't know who changed what, why, how, when, and so on and so forth. We knew nothing, in fact, because we were like introducing changes like crazy. One day we changed we bumped the OS to Trusty, we bumped the kernel and replaced the NFS server version. So yeah, in one day, yeah. So yeah, we had to change something. At least Facebook did. They changed the motto, move fast with stable infra. We probably missed that because who cares about stability of non-production environments, right? We fucking should, in fact. Because if not us, then who? So we realized that if you cannot test your infrastructure changes reliably, you are building nothing more but a time bomb. So we need tests. Or we need to know that base behaves. Base is the name of my company. So we started creating them. Different scenarios like service deployment with locked environment. You have a running service, you lock the environment, you want to deploy the service or you're deploying the service, and it should end with a certain status code and with a proper output message. This is what we are testing. Or increasing number of HTTP workers. You have a running service, you increase the number of HTTP workers, you let Nomad do its magic, and you expect that new workers will be alive and they will be attached to the routing. Or worker not responding to a health check. Do you know what happens in your environment? Are you sure it will be detached from the routing? So yeah, we started testing the stuff. And we also created a service to help us. It's available at FutureSimple/FaaS. It's a failure as a service, and it provides many misbehaviors as a service. So you can, for instance, through API, HTTP API, you can kill it and test if you have working supervisor that can bring it back. You can tell the service to start allocating memory like crazy. And you can see if it's gonna be eventually killed by OM killer or maybe not. If it's gonna be killed when your limits are reached or maybe when it's a gigabyte more. You can, for instance, also tell it to generate shitload of logs and see what happens there then. Or stop listening on TCP. So the process is still running, but it's not responding to TCP health checks. What are benefits of that? It drives design. It reduces fear of change. It makes your infrastructure to be continuously validated. And when something is broken, you have rapid feedback. I don't know if you know this song. Thank you. Questions? Do you have any questions?
Come on.
Okay, thank you.